Hi, my name's Iain Duncan. I'm the author of Scheme for Macs, open source Macs MSP external for scripting Macs with Scheme Lisp. And in these videos, we're looking at the new features in the 0.2 release. This video, we'll be looking at the transport integration functions. All right, let's get started. Okay, here we have a Macs patch with the transport. I'm just going to clear out these consoles. And what I've done is I've made a transport object and hooked up message boxes underneath to show us the bars, beats, and ticks of the current location, the current tempo, the time signature, and the absolute value in ticks. Now this is the exact same as using the global transport window in the Macs extras. However, the global transport window is rather small and you can't make it any bigger. So for the purpose of the video, I've made this transport object with larger windows. The metronome on top of it sends a bang every 100 milliseconds so that these values update, because they don't all update instantly, but they do all update if you are sending it bangs. So we're going to set it to 0 and start the transport rolling. Okay, we can see it rolling. I'll stop again and reset it to 0. Now over here, I've got a file with the new transport integration functions in Scheme for Macs. The first one is transport state, and if we evaluate that, it will give us a true if the transport is running and a false if it's not. There we go, false. Here you can see it in the harder to read Macs console. And we can set the state, again with true and false. Let's start it running. It's running, and we can stop it. Now you'll note that the scheme functions use true and false rather than 1 and 0, because that is the standard for Boolean values in Scheme. Macs doesn't have Boolean values, so of course you send 1 and 0 to transport over on the Mac side, but all of the functions converting back and forth between Scheme and Macs take care of that for us, so we'll be using true and false on the Scheme side by default. Okay, we got a few other integration functions right now. Let's take a look at setting the BPM. It's already at 120, so we'll set it to, say, 100. And you can see the tempo updates. Now, curiously, Macs does not have a native function in the SDK for asking for the current tempo. I could certainly make one out of some of the primitives, and I will do so, but I haven't done so yet. However, we can ask for the transport time signature, and we get a list of numerator, denominator, and we can set it with this 2-argument function. So let's set it to 68. There we go. And back to 44. We can get the absolute value in ticks. These are fractional ticks for where the transport currently is. If we have the transport running, try that a few more times. We can see continuing, and we can reset it with transport seek. Now it's not called transport tick set because transport seek is the name of the function in Macs already, so I chose to match that. And there we go. We've put it back to 0. We put it back to 0 again. I'll stop the transport. Now there are also about, I think it's 9 to go all the different ways, helper functions for going from ticks to milliseconds and to bars, beats, units notation while being aware of the settings of the transport. So that means they take into account the tempo of the global transport. So let's look at ticks to milliseconds. Macs uses 480 ppq, parts per quarter, for ticks. So if we have the tempo at 120 and we ask for the millisecond value of 480 ticks, we will see, there we go, 500 milliseconds. And if we go the other way around and we ask for how many ticks are in 1000 milliseconds, we'll see 960 ticks. If we change the tempo, those values change. We can also do the same thing with the bars, beats, units. So let's make this 960 and ask for ticks in BBU, and we get a list, 1 bar, 3 beats, 0 units. Now the counting in the BBU notation is a little unusual, but this is how Max does it. So this is the point that is the downbeat of beat 3. So 960 ticks from 0 takes you to the downbeat of beat 3. It's easy to get that confused. And we have conversion functions going the other way as well. So that gives you an overview of all the transport integration. Now, right now, they all use the master global transport. We don't yet have support for named subtransports. I will be attempting to add those in the future, but at the moment you're limited to the global transport. And in the next video, we'll look at the scheduling, clock, and delay functions and how those can interact with the global transport.